All right, good morning. Good morning, everyone. Hope everyone's doing all right. Sorry for running a few minutes behind. Let's check something else real quick and then we'll get rolling. All right. So before I get into looking at 12:1 today, bless you. All right, so before we get into 12.1 today, any questions? Everybody good? Everybody straight? Okay. So don't forget, when we look at what we've covered up to this point as far as lectures are concerned, we have this one block of information right here, 3, 3, 4, 8, 5, 6, 9, 5, 9, 6. That was our first test, right here, that post test. Then we have chapter 10 that we closed out last week, 10.1 through 10.6, and that's our second test at some point. You knock those out as well. So just giving you a reminder of what's up there. Remember the review and the quiz, they're two, they're not mandatory. It's just the homeworks and their tests. So these were up here. I left the review quiz because some people like to get, more practice. I put the test review up here because that gives you a good idea of what's going to be on the actual test. So the quiz is not set up that way. So that's the purpose of both of these. They had already generated this review quiz, so I left it. I created this test review so that you'll know pretty much what's going to be on that actual test. But once again, neither one of those are mandatory. But your homework and the test is what you have to do. All right. Everybody good? Anybody any questions in Zoom? Everybody straight? Is that okay? All right, so let's look at exponents. So 12.1 exponents. So when we look at 2 to the third power, so I highlight this where I want the base, the bottom number right here. The regular size number is your base. And then the other number, the superscript number up to the right, is your exponent. All right. So if I have 2 to the third power, that means you're going to take the base, multiply it to itself 3 times. So that's 2 times 2 times 2, which is 8. Now, if you were to switch the roles, that does not give you the same answer. If the base is 3 and your exponent is 2, and that's 3 to the second power, that means you're going to multiply 3 times itself twice, which will give you 9. So the positioning does matter. Just make sure you're not getting into a familiar situation in which a lot of people would do 2 times 3, which is 6. So make sure you don't do that, of course. But 2 to the third power is 2 times itself 3 times, which is 8. 3 to the second power is 3 times itself twice, which is 9. Questions on that and how that works? So an exercise that you may see is right down here says write by using exponents. So if I have 2x times 2x times 2x times 2x, they didn't ask you to simplify, they asked you to write by using exponents. So this is 2x raised to the 4th power. All right. So now I'm going to get into the rules, but evidently somebody must have asked the question right here, so I can go ahead and talk about it. Our exponents rules, we'll cover this. If I have 2x raised to the fourth power in parentheses like that, that means that that 4 needs to be applied to both. So that's why I have 2 to the fourth, x to the fourth, and 2 to the fourth, 2 times itself, 4 times will give you 16. And x to the fourth is just x to the fourth. Like I said, we're going to revisit this when we get to the exponent rules. Someone must have asked the question during my last class, and that's why I went through it. And so here in the red, notice having parentheses, what that means for us versus not having parentheses. So if I have parentheses, like I have in this first one, the exponent of 4 is being applied to both the 2 and the x. But if I do not have parentheses, that 4 is only applied to the x. So, yeah. Yep, so that's the major difference. So same thing as if I have xy to the third versus xy to the third. This means that x and y is affected by that 3 because both of them in parentheses. But if it's not like that, the only thing that's affected by that exponent is what's right up against it, which is just the y. So that's why the parentheses makes all the difference in the world. All right, just another example of what we just finished referencing. If I have x times y times z in parentheses, that 5 is going to touch each one of those letters. But if I only had if I had x, y, and z with no parentheses raised to the 5th power, only the z is affected. So what's right up against your exponent is what will be affected. Right. Mm-hmm. Anybody holding on to 2x to the 4th? All right. So when it comes to negatives, same thing applies. If you want your exponent to be affected, well, let me say, if you want your negative to be affected by the exponent, you have to use parentheses. So that's what happens here. I have -4 in parentheses squared. So that means -4 is being squared. So -4 times -4 is positive 16. But if there was not a parentheses, like right here, the only thing that's being squared is the 4. So the negative will still be sitting on the outside, never affected by the exponent. So the answer would be -16. So you see how there's a difference in, in using parentheses or not. All right, scrolling up. And then here we have a fraction, -4/5 raised to the third power. So that just means you multiply -4/5 times itself 3 times. So -4 times -4 times -4 will give you -64. And then 5 times 5 times 5 will give you 125. So you just multiplying across. Negative to a negative turns positive right here. And then you're left with still a negative. So that's why it's -64. This right here doesn't have anything to do with exponents. I know that was an extra question somebody must have asked. So. There's 3 of them. So now if it was 4, it would have been negative to negative turn positive, then negative negative turn positive. So all I would have had left was positive. So if it's an even number, you'll be left with positive, but if it's an odd, you'll still be left with a negative. So even if that was an exponent of 101, I may not know what 4 to the 101 is, but I still know my answer is going to be negative because it's odd. Let's scroll up. Anybody? All right, so let's get to the exponent rules. Like I said, the other part was an extra question somebody asked. Should be 10 of them, but we'll get to them. So as long as our base is the same, looking at this first one, our base is the same. When you multiply, you're going to add your exponents. We're going to do examples reinforcing all of these rules, but we're just walking through the rules right now. Same thing with the second one. As long as our bases are the same, when you divide, you're going to subtract your exponents. Now, rule 3 is what we were just talking about. When you distribute that exponent into the parentheses to each term that's being multiplied together. Rule 4, the same thought process is just that when you're dividing, it has to hit both top and bottom. Let me copy those down before I get to rule 5. All right, so dealing with negative exponents, I have x to the negative m here. In order to rewrite it with a positive exponent, I can drop it down into my denominator. So that's what happened here. And then the same thing happens if I have a negative exponent in my numerator. To make it positive, I rewrite it in my, if I have a negative exponent in my denominator, excuse me, I rewrite it by writing it in my numerator. And the same things happen here. If I have x over y, but I have a negative exponent, if I apply that negative, it just flips my fraction. So that's what the negative exponent does for us. And things in the numerator, take it down to the denominator. The denominator takes it up to the numerator. And then you can rewrite it as a positive exponent. And this is a little example right here. Like I said, we're gonna do some more. 5 to the negative second power. To rewrite it, you drop it down in the bottom. So there's 1 over 5 to the positive second power. And then 5 squared is 25. So it's 1 over 25. And last 3, this one should have been done earlier. I think I forgot it. I was trying to figure out what was my 10th one, so I made a mistake and left that one out. But anything to the first power is x, anything to 0 power is 1. I mean, anything to the first power is itself. Anything to the 0 power is 1. And then here, x to the m raised to the nth power, you're raising something, a power to another power. You're going to multiply those exponents. So let's try these formulas out. So we're looking at the first one first. You have x to the m times x to the n is going to be x to the m plus n. Once again, if your bases are the same, when you multiply them, you're just going to add your exponents. So if we look at this first one right here, w to the third times w to the fourth. So that means when we multiply them, add an exponent, 3 plus 4 is 7. So really what's going on here is I have 3 w's in that first, w to the cube third power, 4 w's in that w to the fourth power. So 3 plus 4 is 7. So altogether I have 7 w's. So that's the foundation of all that. So all of these rules, you can break them down that way and look at them foundationally. It's just that you don't want to have to do that. If they give you, like this one, 2 to the 11th, you don't want to have to write out 11 2 just to see, what's going on, but that's what's happening. So yep, all of them foundationally can be broken up that way. So 2 to the 11th times 2 to the 8th, just add your exponents. That's 2 to the 19th. Now, when it comes to 2 and some numbers, they will expect you to go ahead and multiply out. Like if you had 4 to the third power, 64. 2 to the third power is 8, 2 to the fourth power is 16. They may even go as high as 2 to the seventh power and expect you to do 128, but most definitely they will not expect you to do 2 to the 19th. So you could leave it as 2 to the 19th. But Math Lab will let you know it's the right answer, but can be simplified further if they really want it from you. All right. So this next one, this y times y to the 9th times y to the 17th. So when you just see y, remember I mentioned that x to the first power is the same thing as x. they will assume you know there's a y there for the exponent. So that will be 1 plus 9 plus 17. And like I said, they would expect you to know that when you don't see anything, that there's a 1 there. And so that's going to be y to the 27th. All right, so last one under this rule, we have 8b to the 5th, 8 to the 3rd, b to the 8th. You multiply all of these together. But remember, the rule applies to like bases. So what you can do is couple together the a variables and then couple together the b variables and simplify those. So we have a times a to the 3rd, b to the 5th times b to the 8th. And then you just add your exponents accordingly. So that's 1 plus 3, which is 4, 5 plus 8, which is 13. And then that's where you would stop. So there's nothing else you can do with that because they're different bases. All right, questions before we go to the next rule. So once again, when you multiplying terms that have like bases, you're going to add the exponents. So next one is division. If we divide on like bases, then we can subtract our exponents. So t to the 6th power divided by t to the 4th power. 6 minus 4 is 2, so that's t to the 2nd power. Then we have 5 to the 10th over 5 to the 8th. 10 minus 8 is 2. And then once again, that goes back to what I was saying, those we didn't leave as 5 squared. That is something they are expecting you to multiply out. So there's a small enough number, a small enough calculation in which they expect you to multiply that out. So 5 squared would just be 25. All right. Then one more, y to the 15th divided by y to the 8th. That'll be y to the 7th. 15 minus 8 is 7. Trying to see how much more or how deep we're going there. Okay, cool. Any questions before I go to the next thing? Pretty good. All right. So let's look at the next one. This was actually rule 10 for us because I remember I did that last one out of order. So whenever you're raising a power to a power, you're going to multiply those exponents. So if I have s to the fourth raised to the second power, that's going to be s to the 4 times 2, which is s to the 8th. Same things if I have 3 to the 10th raised to the 5th power. Just multiply your exponents. And that's 10 times 5, which is 50. And then the next one, we have x to the second, x to the 5th, raised to the 4th power. Now, if you wanted, you could distribute the 4 to each one of them, but since they're like terms or like bases, what I would do is add them to, make them one singular term. So x squared times x to the 5th is x to the 7th. Now you have x to the 7th raised to the 4th power. That means you're going to multiply. 7 times 4 is 28. Excuse me. And problems. So that was 3. Yep. Okay. All right. So next one, when we said that when we don't have like bases and we have an exponent sitting outside the parentheses, then we're going to distribute that exponent to each term inside of your parentheses. Thank you. So we have -2 x, y, z raised to the 4th power. All of those are in the parentheses. So notice the 4 has to be applied to each one of those. So it's -2 to the 4th power, x to the 4th power, y to the 4th power, z to the 4th power. All right. So -2 times -2 times -2 times -2 will give you a positive 16. Then x to the 4th, y to the 4th, and z to the 4th. All right, next one, 5x squared, y to the 7th, raised to the 3rd power. So once again, all of those in the parentheses, so they need to be affected by the cube. So there's 5 cubed, x squared cubed, y to the 7th cubed. Now 5 cubed is 5 times itself 3 times, so that's 125. And then we see in the green circles here, going back to our previous rule. Yep, rule 3. So a power to a power means you're going to multiply. So x to the second raised to the third power will be x to the 6th. Y to the 7th raised to the third power will be y to the 27th. Questions? Any questions? All right. Now exponent being applied to a fraction. So that exponent needs to be applied to both numerator and denominator. So if I have 2 to the 5th raised to the third power, so that's going to be 2 cubed over 5 cubed. 2 cubed is 2 times 2 times 2, which is 8. 5 cubed, 5 times 5 times 5 is 125. Next one, 2x cubed over y to the 5th, all raised to the second power. So that 2 needs to be applied to each piece that you see. So that's going to be 2 squared, x cubed squared, y to the 5th power squared. So the square needs to be applied to each different base that you see. Two squared is 4, x to the third power squared is x to the 6th, multiply your exponents. And y to the 5th squared is y to the 10th, once again, multiplying your exponents. All right. Questions, any questions? Okay. Do this one, that one. Okay, we'll save negative exponents to the next section. Okay. All right. Cool. This. All right, so let's look at this one. Wait, anybody holding on to this? I don't know this one. We gotta do. All right, so let's look at this one. So let's say if we have x to the second power raised to the 6th power times x cubed all over x to the seventh power raised to the second power. All right. So power to a power. We're going to multiply. So 2 times 6 is 12. On the bottom, 7 times 2 is 14. Then up top, we can add these together because we're multiplying your exponents. I mean, multiplying your bases. So you add your exponents. So 12 plus 3 is 15. And now, because we're dividing, we subtract. 15 minus 14 is 1. And that'll be x. X to the first power is just x. All right, so 3cd squared times 2cd cubed is raised to the third power. So in that second parenthesis, since I have the 3, the third power on the outside of the exponent, or outside of parentheses, the outside exponent or outside of parentheses, I have to apply that to everything on the inside. And that's what's going on in the second row. The first one didn't, wasn't affected by anything, but the second one, that's 2 to the third power, c to the third power, d cubed, cubed. This right here. Okay, well, yeah, that's the same one, right? Right there. It's just that it's being cubed by this one. Mhm. All right. So 2 cubed is 8. C cubed still C cubed, but here we have to multiply these exponents. So that'd be d to the 9th. And now we can bring everything together that can be simplified. So notice I have 3 times 8, c times c cubed, d squared times d to the 9th. All right. So before we finish it off, let's locate what we did. So you bring your numbers together, your regular numbers, your bases, 3 and 8. Bring your c's together, c and c cubed, and bring the d's together, d squared, d 9th. From there, you add your exponents with 3 times 8 is 24. C and c cubed is c to the 4th. Add your exponents, and then d squared, d to the 9th, d to the 11th. Add your exponents once again. All right. Make sure we did. All right, we good. Go up. Go up. All right, so anything to the zero power is one. We mentioned anything to the first power is itself. Then when it comes to the zero power, anything to the zero power is one. So 4 to the zero power is one. X to the zero power is one. -4 to the zero power. Now notice the parentheses. That means the zero power is being applied to everything. It's going to be one. If you don't use parentheses, that means the zero is only applied to the 4, and the negative is still going to be there. It was not affected by the exponent. So once again, talking about the effectiveness of the parentheses versus not having the parentheses. Same thing here. -4x to the zero power without parentheses. The zero is being applied to just the x, and that turns the x into one, but -4 is still there. So -4 times one is just -4. But then if I have parentheses over everything, around everything, that's just going to be one. Any questions? Before we go look at one more section. So the negative exponents, those were negative exponent rules that I gave. That's for another section that we'll get to later. So we'll get negative exponents later. We're gonna go to something else, but that's where this section stops. Zero exponents. Let's do this. All right, so 12.2 is on adding and subtracting polynomials. And a polynomial is just an expression that has variables, operations, exponents, etc. So a couple examples, if x plus 5 is a polynomial, 15x squared is considered one, it's a monomial, and 3x cubed plus 7x minus 9, another example. All right, so in your polynomial, you're gonna have terms. They're separated by plus and minus signs. So if I have 3x cubed plus 7x minus 9, I have three terms there, 3x cubed, 7x, and then -9. All right. Write it down with terms. Let's scroll up some. Then coefficient. That's the number in front of the variable. So going back to that same expression, 3x cubed plus 7x minus 9. For the term 3x cubed, the coefficient would be 3. For 7x, the coefficient is 7. And for -9, the coefficient is just -9. I probably should have called this something else instead of 3. I might do that for next time. -4, 7. All right, any questions on anything so far? Just talking about just basically vocabulary, just so that if math lab reference these words, at least you know what the words are and what they're talking about. So the degree of a term is the exponent on the variable. So we have 3x to the fourth plus 7x minus 9. 4 is going to be the degree of 3x to the fourth. 1 is going to be the degree of 7x. And then -9, since it has no variable at all, then 0 would be the degree of that term. Mhm. Then the degree of the polynomial is the largest exponent in the polynomial. So in this case, the degree of the polynomial will be 4. Good. And last one, the constant is the number that is not attached to a variable. So in our case, constant will be -9. All right. Descending order is when you arrange your terms from largest to smallest according to your exponents. This is one we normally use. You know, we try to set our polynomials up in that fashion. 5x to the 7th plus 4x to the 6th plus 3x cubed minus 2x minus 8. So your highest exponent all the way down to your lowest. Then ascending order is just doing the opposite, arranging your terms from smallest to largest according to your exponent. So you just rearrange all your terms in the opposite direction. So -8, -2x plus 3x cubed plus 4x to the 6th plus 5x to the 7th. And so notice whatever's negative stays negative, whatever's positive stays positive. Always make sure you hold true to the signs that you were given originally. Few more terms. Right done with ascending order. So monomial is 1 term, binomial 2 terms, trinomial 3 terms. And polynomials is 4 more terms. Poly means many. Everybody okay? Go on to the next page. All right. Make sure I got All right, so now let's go and get into adding and subtracting these polynomials. So in order for us to do that, we have to combine what we call like terms. So like terms are terms that have the same variables, same amount of variables, same exponent on your variables. If anything's different, then they are not like terms. You cannot add them or subtract them from each other. So like terms, here we have 5x, 3x, negative 10x squared, negative 17x squared, negative 39x squared y, 101x squared y. And then even having just regular numbers without any variables at all are considered like terms. Those numbers you normally add together anyway, but those are like terms. These are all examples of like terms. If anything's different with the variables, with the exponents, or anything attached to your numbers, they are considered unlike, and you cannot add them or subtract them from each other. So here, 5x and 3, one has x, the other one doesn't. So you cannot add them to each other. 10x squared, negative 17x, one has the power of 2 on the x, the other one doesn't. Same thing here with negative 3x squared y and 101xy. So one has the power of 2 on the x, the other one doesn't. Even though both of them have x and y, there's still something different, so we cannot add them or subtract them from each other. So next few things, similar scenarios, but something different in each case. I just want to emphasize or re-emphasize what we can and cannot add to each other. So the first scenario, we have 5x plus 3x, and that'll give us 8x. And the next one, 5x plus 3. One has x, the other one doesn't, so you cannot add them together. So that expression is already in lowest terms. There's nothing you would be able to do with that. The third one, we have 5x plus 3y. Once again, something's different here between our two terms. One has x, the other one has y. So you cannot add them together. That's already considered being in lowest terms. Fourth one, 5x squared plus 3x squared. Both of them have x squared. So you go ahead and add the 5 and 3, give you 8. Notice that's 8x squared. So we don't change the exponent. And then in the last one, 5x squared plus 3x. One has the power of 2, the other one doesn't. So you cannot add them together. And it's already in lowest terms. Questions? Any questions? So let's look at adding and subtracting polynomials. So what you're going to do here, all you're going to do is combine your like terms. If something is not like, then it's just a part of your final answer without any alteration, I would say. So let's say if I have 7x squared y plus 20x squared y minus 8, then your like terms are the 7x squared y and the 20x squared y. So 20 plus 7 is 27. And then the minus 8 just comes down as a part of your final answer. So, oh, sorry, I had an alarm. So all we're doing is combining all like terms. Mhm. All right, so if we have negative 3c cubed plus 5c squared minus 7c plus 11c cubed plus 6c squared plus 3. So once again, we are combining like terms. So we have negative 3c cubed plus 11c cubed, and that gives 8c cubed. 5c squared plus 6c squared is 11c squared. Now, there's nothing I can combine negative 7c with, so I just bring it down. Same thing with the plus 3. Just go ahead and bring it down, and that's our final answer. 8c cubed plus 11c squared minus 7c plus 3. Same thing happens here. We have 4w squared minus 2x plus 3w squared minus 4x squared plus 6x. Once again, you combine the like terms. Whatever's not, whatever doesn't have a term to combine it with, you just bring it down as a part of your final answer. So 4w squared plus 3w squared is 7w squared. Then we have negative 2x and a positive 6x. So it'll be positive 4x. Then the negative 4x squared, you can't combine it with anything, so you just bring it down as a part of your final answer. All right. So we look at subtraction, then we'll be done for today. Wrong button. All right, here we go. So if we have negative 4p to the fourth plus 5p squared minus 3 minus the quantity of 11p squared plus 4p minus 6. So this minus sign, whenever you're doing the subtraction, the minus sign that's sitting in front of a parentheses has to be distributed to the one that follows. So that minus sign needs to affect each one of these terms in this parentheses. So all of these will stay the same. All of these will be the opposite. So that's what I got going on down here. So that's negative 4p to the fourth plus 5p squared minus 3. And that's negative 11p squared minus 4p plus 6, because negative turns positive. All right, so combine our like terms, negative 4p to the fourth. We don't have another p to the fourth, so that just comes down. Then we're looking at negative 5p squared. I said negative, positive 5p squared and negative 11p squared gives you negative 6p squared. Minus 4p doesn't have a term to combine with, so you just bring that down. And then we have negative 3 and a positive 6, which would be positive 3. And so that's our expression. And got one more. Make sure we're okay. We have a squared minus 2ab plus 7b squared minus negative 8a squared minus 6ab plus 2b squared. So once again, that minus sign needs to be applied to each term that follows in that parentheses. So that'll turn into a positive 8a squared plus 6ab minus 2b squared. And then from there, combine your like terms. A squared plus 8a squared is 9a squared. Negative 2ab plus 6ab, that'll be 4ab. And 7b squared minus 2b squared would be 5b squared. And that will be your final expression. Questions, questions, questions. So that's 12-1 and 12-2. Next class, we'll jump into 12-3 and keep moving from there. And you guys let me know if you have any questions. Knock them out. But if not, if y'all do y'all thing and you test done, I'm good. So any questions before we close? Any questions? Any questions? So you guys are good. I'm good. I'll see you next class and we'll pick up where we left off. All right. See you soon. Anybody else? I see thumbs up in Zoom land. All right. So you guys have a good one and I'll see you next class. See copying, so I'll wait. Right. Oh, yeah. All right, everybody, my copy. Sure. All right.